Why the sun has been burning for 4.6 billion years. The sun's been burning non-stop for 4.6 billion years, and it's still going strong. Hard to believe, right? First off, let's clear up a huge misconception. The sun is not a giant ball of fire like a cosmic campfire. It's not burning wood, it's not plugged in, and it definitely isn't running on batteries. And yet, it shines with a brilliance that seems like it'll never end. So, what kind of fire lasts this long? The answer lies in a process called nuclear fusion. Sounds intimidating? Don't worry, I'll break it down in the simplest way possible. The sun is a massive ball of gas, mostly hydrogen and helium. Deep in its core, temperatures soar up to a mind-blowing 15 million degrees Celsius. At that heat, hydrogen atoms get squeezed so tightly together that they fuse into helium. And every time that happens, a tiny bit of mass is converted directly into energy, the same energy that reaches Earth as light and heat. This fusion process is like a natural power plant. No switches. No batteries. Just non-stop, clean, self-sustaining energy. Now you might be thinking, wait, after all these billions of years, isn't it running low? Actually, nope. Every second, the sun fuses about 600 million tons of hydrogen. Sounds like a lot, right? But according to scientists, it has only used up about half of the hydrogen in its core. If the sun were a giant gas tank, it's still got enough fuel left to cook, shine, and warm us for about another 5 billion years. So relax, you've got plenty of sunlight left to sunbathe, grow plants, and hang your laundry out to dry. But still, when will the sun die out? Short answer. Not today. Definitely not within the next few million years. But wait around 5 billion years, and yeah, it's going to happen. As hydrogen runs low, the sun will enter its old age. It won't be able to generate energy the same way anymore. The core will start to shrink. But the outer layers will expand, and the sun will grow into a red giant. So big, in fact, it could swallow up Mercury, Venus, and maybe even Earth. Eventually, its outer layers will drift off into space, leaving behind a dense core known as a white dwarf. No more energy production. That white dwarf will slowly cool, dim, and eventually disappear into the void. Like a candle that's burned all the way down. But don't get too emotional yet, that final fade out could take tens of billions of years. This isn't a tragedy. It's the natural life cycle of a star like our sun. And right now, the sun is still in its prime. Its most powerful, energetic phase. So if the world ever ends because the sun dies, that's a problem for the far, far future. For now, we've got more pressing things to worry about. Like that power bill. The meeting tomorrow. What's for dinner? And maybe whose playlist you're vibing to tonight. But wait, why doesn't the sun just explode? I mean, fusion is powerful stuff, right? Here's where things get really fascinating. The sun's stability comes down to a perfect balance. A cosmic arm wrestling match between two opposing forces inside the sun. On one side, the outward pressure from nuclear fusion. On the other, the inward pull of gravity, thanks to the sun's massive mass. Fusion wants to push the sun apart. Gravity wants to pull everything back in. And for 4.6 billion years, they've been locked in a stalemate. That's why the sun stays round. Doesn't collapse. Doesn't blow up. This delicate balance is known in astrophysics as hydrostatic equilibrium. Sounds peaceful, right? But in reality, it's a constant tug-of-war at unimaginable scales. Now, what if the sun just disappeared? Sounds like sci-fi, but imagine it for a second. First 8 minutes. Nothing changes. Because sunlight takes about 8 minutes and 20 seconds to reach Earth. So even if the sun blinked out instantly, everything would seem fine. For a few minutes. You'd still be sipping coffee. Checking your phone. cars still zipping down the street. Then, darkness. Total, endless darkness. No daylight. No moonlight either, since the moon only reflects the sun. No more sunrises. No sunsets. Just cold, eternal night. Within a week, Earth's average temperature could drop below -20 degrees Celsius. After a few more weeks, down to -70 degrees Celsius. Oceans would freeze from the surface down. Plants would die first, no light, no photosynthesis, no oxygen production. The food chain would crumble. Next. Insects. Birds. Then, us. Without the sun's energy, life as we know it ends. Some bacteria and microorganisms near volcanic vents deep under the ocean might hold out a little longer, living off geothermal energy. But that's it. The last flickers of what was once a vibrant Earth. So yeah, next time sunlight's too bright and you're squinting or hiding from it, just remember, that light is keeping our entire planet alive. The sun isn't just a glowing object in the sky. It's the backbone of all life. And you're literally orbiting it, not metaphorically, but for real. The sun is the power source of Earth's entire ecosystem. No sun. No green planet. Just a frozen rock, drifting lifeless in the void. And the most amazing part? All that energy comes from squeezing hydrogen atoms together. No firewood. No fossil fuels. No gas. Just physics. And an unimaginable amount of heat. The sun is living proof that nature can build machines far beyond anything humans have ever invented. So here's the big takeaway. The sun doesn't burn. It fuses. It's a massive natural nuclear fusion reactor that's been running smoothly thanks to a perfect balance between fusion pushing out and gravity pulling in. And because of that balance, it keeps shining, heating, and sustaining life on Earth. You used to think the sun was just a flying fireball, didn't you? Don't worry, I did too. But now you know, it's not burning. It's fusing, like a boss, for the past 4.6 billion years. And still no sign of calling it quits. So if you think the sun is absolutely legendary, go ahead, like this video, subscribe, hit that notification bell, and leave a comment below. Who knows? Your question might be the next topic we explore. Until then, stay curious, and see you next time.